This is Dr. Obulakonda Reddy, Professor, Department of CSE, Cybersecurity. Today we'll discuss on cluster classification and community components for clusters. Before going to this one, we'll see first, this is the references. I was collected data from these resources. Now coming to the topics, cluster classifications and community components for clusters. Now see here, cluster classifications. The theory of cluster classification that will be focused on 5 areas. And first thing, the outline of this one is application target. So this application target will gives to high performance clusters that has to be a grand challenging applications and high availability clusters. And second thing, we see that high availability clusters, mission critical application that will focus on mission critical applications. So this is the first type of cluster classifications. And then see the second type is node ownership. In a cluster, each system will take as a node. Now, node ownership, dedicated clusters, non-dedicated clusters. We have observed the two classifications to here. Dedicated clusters, the node purely for a specific applications or specific purpose. For example, we have assumed that this is a node nothing, this is the number of nodes, node number 1, 2, 3, 4. We have a 50 systems in a cluster. Then dedicated, I am talking about the dedicated clusters. So this system node 1 purely for a one specific application or specific purposes. Only for these purposes we have to use this node. So that is called as dedicated clusters. In node 1, for example, in this example, that will be assigned for a specific applications or specific purposes. And the second thing is non-dedicated clusters. This is sharing or multi-purposes. These nodes, for example, I use a fourth node. This is for a sharing or multi-purposes. I use this node as a sharing the resources or multi-purposes. So the type of node is non-dedicated. So non-dedicated in the sense that is a sharing the content, sharing the resources. That are adaptive parallel computing, communal multiprocessing. So this is the node, under the node ownership we have seen the dedicated clusters, non-dedicated clusters. To the two types we have observed. And the third classification type is node hardware. What type of hardware used in a node? So cluster contains a different nodes to here. So inside what type of in a node nothing but a one system, internally high performance systems. In that one, what type of hardware? Now we talk about the node hardware. What type of hardware used internally? So clusters of PCs, COPS. So clusters of PCs, COPS, COPS, and piles of PCs, POPs. So which are the internal to use, and the cluster of workstations, COS, COWS, and clusters of SMS, symmetric multiprocess. Simply we say the clumps. Clusters of SM, symmetric multiprocessors. So these are of the we discuss with the hardware, node hardware. And the fourth thing, under the outline of this slide is node operating system. What type of operating system using cluster nodes? Linux clusters. Examples, BOFs. So examples are BOFs. Then that used for a Linux operating systems. Second thing is a Solaris clusters. That is Berkeley now. Includes the Berkeley now and use the Solaris operating systems. And third one is a new technology, NT clusters. That is used for high performance virtual machines. Examples include that high performance virtual machines that use NT operating systems, and AIX clusters. Examples are IBM SP2 that use AIX operating systems. The next thing is a ISO or compact clusters. This is used Unix way. So that is used for SEO compact clusters. Unix operating system that was use the Unix operating systems that is use SEO and compact clusters. And digital VMS clusters. Other thing is a digital VMS virtual machines. So, digital virtual machines clusters. And so next one is a HP UX clusters, Unix clusters, which has to be used Hewlett Packard and Microsoft Wolfpack clusters. So these are all the different operating system, node operating systems using internet. This is the fourth category. And fifth one is node configurations. See the node configurations. This is homogeneous clusters, heterogeneous clusters. You know the meaning of homogeneous. That is the same structures, same architectures, similar architectures run the same operating system. The node will have similar architectures and run the same operating systems. Heterogeneous is a different. Nodes will have different architectures and run different operating systems. The configuration we have focus on. It will discuss about the two things. No? Homogeneous clusters, heterogeneous. Homogeneous in the sense it is the similar architecture and same operating system. And heterogeneous is a different. Nodes will have a different architecture and run different operating systems. So this is cluster classifications. The outline of this slide is levels of clustering. What are the levels we see here? Levels of clustering. So first one is a group clusters. The group clusters will have the number of nodes will have 2 to 99. That is combination of the number of nodes will have 2 nodes to 99. Nodes are connected by SAN like MyraNet. And the second thing is a departmental clusters. Departmental clusters. The number of nodes will have formed to 10 to 100 systems. 10 systems to 100 nodes. And organizational clusters. Another third one is the organizational clusters. The number of nodes are many hundreds. And national meta computers. That is WAN internet based. This will focus on WAN or internet based. And international meta computer. That is based on internet based. And number of nodes are thousands to many millions. This has to be do with meta computing, web based computing, agent based computing. So in this international meta computer that will discuss about that meta computing, web based computing, agent based. But these two, either web based and agent based. This is the Java plays a major role in web and agent based computing. This is the purpose we use for Java. So now up to that point we have discussed with a cluster classifications. What is the way we have to differentiate with the classify the clusters. Classify the clusters. Now see the next thing is community components for clusters. So first thing we'll see with the processors. The high performance computing relies community components for clusters includes processors, memory, disks, and different things. Now, first thing we will discuss with the processors. The processor will have Intel 86 processors that have Pentium Pro and Pentium GR. And AMD 86, AMD processor, Cryx, etc. So Intel processor that used to Intel 86 processor that include this type of processor. Digital. Next thing is the second thing is a digital alpha. That is alpha 21364 processor that have integrated with a processing, memory controller, network interface into a single chip. total networking that has to be included into a single chip. And other processor are IBM PowerPC, SunSpark, and AGI MIPS, Tablet Backward PA, and IRAM, Berkeley Intelligent RAM. So Berkeley systems, Berkeley that have a intelligent RAM, integrate processor and DRAM. This IRAM integrate processor and DRAM onto a single chip. The outline of this slide will focus on your processors. This is the first commodity components for cluster. This is high performance commodity components for clusters, include the processors. And the second thing is a memory and cache memory. So memory, standard industry memory model, that is called as a SIME, standard industry memory model, and extended data out, that is called EDO. Allow next access. What is that? This thing is focused on to that. Allow next access begin while the previous data is still being read. EDO. Next, fast pace. Next thing we'll discuss about the fast pace. Allow multiple adjacent accesses to be made more efficient. Access to DRAM is externally slow compared to the speed of the process. Access to DRAM is externally slow compared to speed of the processors. And within Pentium based machines, uncommon to have a 64-bit wide memory bus as well as the chipset that support up to 2 bytes of external cache. So this discuss about the memory and cache memory. Next thing we'll focus on to the disk and IO. Community of clusters include the disk and IO also. So this overall measurement in disk access time has to be less than 10% per year. This is the performance has to be less. Disk accessing time. So overall improvement in disk access time has been less than 10% per year. It is less. Then Amdahl's law, what it states that speed up obtained by from faster processor is limited by the slowest system component. Speed up obtained by a faster processor is limited by the slowest system component. So this is stated about the Amdahl's law. Parallel IO. So parallelly. So at the same time we have the parallel IO, input output. Parallel IO. At the same time it has to be executed with the input and output devices. Carried out IO operations in parallel. Input output operations in parallel. Supported by parallel file system based on the hardware or support for a RAID. Software RAID. Whatever you have carried the IO operations. So internally that have to be supported with a basic hardware and software. Necessary software has to be arranged. So these three things will focus on the disk and IO. Next community components for cluster include the system buses. What type of buses? Different buses we have observed here. ISA bus, AT bus, clocked at 5 MHz and 8 bits wide, clocked 13 MHz and 16 bits wide. First one ISA bus, and the second type is a VISA bus. 32 bits bus matched system clock speed, which has to be matched with the system clock speed. And PCI bus, it contains to 133 megabytes transfer rate and adapted both Pentium based PC and non-Intel platforms. Example, digital alpha servers. And fifth thing, community components for clusters. Fifth thing is cluster interconnect. This is a very important. In between two nodes, the cluster has to be in between a nodes. the communication between the nodes. For example, these are the nodes assume that in between the communication between a nodes. What is the high-speed range? So communicate over high-speed networks. In between nodes, we use a high-speed networks using a standard networking protocol such as TCP/IP or low-level protocols such as AM, amplitude modulations. So in between the communication in between nodes that I have to use for high-speed networks. Each node, like each box will treat it as a node. 1, 2, 3, 4 nodes. Each, for example, 4 nodes here now. So in between, we have a high-speed network to use, like for example, TCP/IP for low-level protocols such as amplitude modulations, and we use for TCP/IP now. And second thing is the standard Ethernet. What is the standard Ethernet speed? That speed has a 10 Mbps and cheap. This standard Ethernet, easy way to provide file and printer sharing. This is the thing. Easy way to provide file and printer sharing. Bandwidth and latency are not balanced with the computational power. Bandwidth and latency are not balanced with the computational power. So that we'll discuss with a standard Ethernet. And next thing is the Ethernet, fast Ethernet, fast Ethernet, and gigabit Ethernet. So fast Ethernet that will be used to 100 Mbps per second. And the gigabit Ethernet preserve Ethernet simplicity, that has to be preserved with a Ethernet simplicity, deliver a very high bandwidth to aggregate multiple fast Ethernet segments. So this is talk about that cluster interconnects. Next, community components for clusters are continue for this cluster interconnects. Asynchronous transfer mode, that is simply we write as the ATM. Asynchronous transfer mode that will focus on switched virtual circuit technology, cell, small fixed size data packet. The cell have with a small fixed size data packet, optimal fiber, that is expensive upgrade, telephone style cable, that is Cat3, and better quality cable for Cat5. And the second thing is a scalable coherent interfaces, that is SCA, which is to use IEEE 1596 to 1992 standard aimed at providing low latency distributed shared memory access cluster. So this is SCA type. And other thing is a point-to-point architecture with the direct, which is with a directory-based cache coherence. Again, this has to focus. This will focus on reduce the delay inter-processor communication, point-to-point architecture. And the second thing is eliminate the need for runtime layers of software protocol, paradigm translation. Next thing is less than 12 seconds, zero message, and length latency on Sun spark. And next thing is scalable SCI, designated to support distributed multiprocessor with high bandwidth and low latency. This is very important. High bandwidth and low latency. Latency is nothing but it is a in-between accessing time in between a nodes. SCI cards are SPACs, bus, and PCI based SCI cards from DAL. And next thing is scalability constrained by the current generations switches and relatively expensive components. Continuation of this cluster community components for cluster is cluster includes cluster interconnect. So Myranet. So this one use interconnecting cluster interconnects that use Myranet. The Myranet will have 1.2 Gbps full duplex interconnection network, that is a 1.2 Gbps. Use low latency cut through routing switches and tolerance fault. It has to, which is able to offer fault tolerance by automatic mapping of the network configurations, which is supported both Linux and new technologies. What are the advantages for cluster? This is the advantages. Very low latency, 5 microseconds, one way, point to point. First advantage, very low latency. The accessing time will take as a very, and the second thing is a very high throughput. Throughput means particular amount of time, how many jobs are completed. And the next thing is a programmable onboard processor for greater flexibility. What are the disadvantages? Now focus on cons also, pros and cons. Now cons, expensive. That will take for approximately $1,500 per host. This is expensive. First drawback this. And second is complicated scale. Switches with more than 60 ports are unavailable. This is complicated scale. Next, community components. Community components for clusters are used operating systems. So, two fundamental services for users. These operating systems will include two fundamental services for user. That is, make the computer hardware easier to use. And the second thing is share hardware resources among users. For example, processor or multitasker. And the new concept of operating system services that has support multiple threads of control in processes itself. Parallelogram within a process, parallelogram. At the same time, it has to be executed with a number of jobs. Multi-threading, the number of threads are executed. POSIX thread interface is a standard programming environment. These are all the new concept in operating system services. What are the trend? What is the trend? Modularity. MS Windows, IBM operating system. Microkernel provide only essential operating system services. High level abstraction of OS portability. This is one. Microkernel. Next community components for clusters is operating systems, which has have a Linux. Under the operating system, we discuss with the Linux. That is follow with a Unix like a operating system. Unix, one of the operating system, runs on a cheap 86 platform. It has offered the power and flexibility of Unix. And second thing is readily available in the internet and can be downloaded without a cost. This is open source. And fix the bugs, easy to fix bugs and improve system performance. Other thing is users can develop or fine-tune hardware drivers, which can be easily made available to other users. Another thing is features such as preemptive multitask. It has to perform with a multitask, demand page, virtual memory, multi-user, and multi-processor support. These are all the features which has to be included in Linux operating system. And the next community is a continuation of these operating systems here. Solaris. This is also a one type of operating systems. This Solaris is discussed on here. Unix based multi-threading, which has to be Solaris is which has Unix based multi-threading or multi-user operating systems, which support Intel 86 processor and SPARC based platforms, which is take with a real-time scheduling features and a feature critical for multimedia applications, and which are supported with a two kinds of threads. First one is a lightweight process and second thing is a user level thread. And next thing is support both BSD and several non-BSD file systems. Berkeley, BSD means Berkeley Software Distributed. Non-Berkeley Software Distributed File System. That has to be a cache FS, auto client, TMPFS, which has uses main memory to contain file system, proc file system, volume file systems. Another thing is supported distributed computing is able to store and retrieve distributed information. And next point under the Solaris is open Windows allows application to run and remote systems. Continuation of this community is operating system. So Microsoft Windows NT. This is also a one type of the operating system, new technologies. So preemptive, it is a Microsoft Windows NT is a preemptive. multitasking, multi-user or 32-bit operating systems, which has object-based security model and special file system (NTFS) that allow permission to set on a file and directory basis, and support multiple CPUs also, which has to support multiple CPUs and provide multitasking using symmetrical multiprocessing, and support for different CPUs, and multiprocessor include the missions with threads. Have the network protocol, which have a network protocol services integrated with the base operating systems. Like several built-in network protocols are IPX, SPX, TCP/IP, NetBEUI, and the API, application programming interfaces. These are all the different examples for application programming. These are all the major community component for cluster, which has to be helps to improve the high performance compute. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.